Chapter 5.2 is solving systems of linear equations by substitution. Now we just learned it in 5.1 how to do it by graphing. This doesn't have any graphing involved. This is all algebra. And we're going to learn how to do substitution. Now when I think of substitution, I think of hockey. There was one year 4 of my 5 kids played hockey in Minnesota. It was crazy. This hockey player is injured. So somebody's going to come in and substitute for him. Just like if I was sick, I would get a substitute. Okay, another example. Here is a recipe for sour cream sugar cookies. And I know that sounds gross, but I promise they're really, really good. Okay, now let's say I don't have any sour cream. I could substitute the sour cream with yogurt and a teaspoon of baking soda. Okay, so again, I'm taking one thing out, putting in something else. I'm substituting. All right, so that is exactly what we're going to be doing with substitution with systems of equations. So one of the equations you need to set equal to either y or x. So you need to get either y or x by itself. And in this case, they've already done this for you. And this is kind of like, say this is me, this is a substitute teacher, here's our class, okay? So I'm coming to class or whatever, and let's say I'm sick. So I'm not here in class anymore, so the substitute teacher needs to come in instead, okay? If you don't like that analogy, basically you're just taking the y, taking it out, and substituting in what y is equal to. So now I have 6x minus 5 times y, but I'm putting in this instead, negative 2x minus 9, that's my y, equals negative 19. So these two equations are exactly the same, except this one has y and this one has what y is equal to. Okay, so now I'm going to solve for x. So I've got to distribute. So I've got 6x plus 10x plus 45 equals negative 19. I'm going to combine like terms. So 16x plus 45 equals negative 19. Subtract 45 from both sides. And I get 16x equals negative 64. Divide by 16 and I get x equals negative 4. And remember, the solution to a system of equations is a coordinate point, right? So I'm going to have an x value and a y value. So I found my x value, that's negative 4, but how am I going to find my y value? Okay, once I find this one, I now take this and I plug it back into one of these. And it doesn't matter which one you plug it back into, you'll get the same answer. So negative 4, I'm going to take it and I'm going to plug it in for this x right here. So I have y equals negative 2 times x, which is negative 4, minus 9. So this is 8 minus 9, which is negative 1. And there is my answer. Okay, so let's do another one. These are the step-by-step. I'm not even going to go over that because sometimes looking at the steps makes it more confusing. It's easier just to show you than to read the steps. Okay, so here we have another one. They gave us y all by itself again, which is nice. So that means that this y right here is going to get taken out. Okay, it got injured, and the substitute is coming in. So if I rewrite this, I have 3x plus 2 times y, which is this. So 1/2 x minus 1 equals 0. Okay, so 3x plus 2y equals 0. That's what I've got right here. Okay, so I'm going to solve for x again. 3x plus, this is going to distribute. 2 times 1/2 is 1. Minus 2 equals 0. So now I've got 4x equals 2. Divide by 4. X equals 2/4, which is the same thing as 1/2. So there is my x value right there. And how do I find my y value? I plug it back in. So y equals 1/2 times x, which is 1/2, minus 1. So here I have y equals 1/4 minus 1, which is 4/4. So y equals negative 3/4. Okay, let me just double check. Okay, just making sure I did that right. Okay, I hope this is making sense, because like I said, this is basically the lesson. Oh, and here it is graphed out for you. So if you graph these two equations, they cross at 1/2 and negative 3/4. Those are, of course, decimals. Okay, so I would like you to try this one. And you can see that y is by itself for both of these. So give this one a good try. And yeah, so pause your video. All right, so if I am taking y is by itself and y is down here, if I take out this y and I put this in for it, then I'm going to have 3x plus 14 equals negative 4x. Okay, let me show you that again. And actually, if you think about it, if y equals this and y also equals this, then aren't they equal to each other? We kind of had some examples like this before when we were doing function notation. Okay, so these two are set equal to each other. All right, I'm going to subtract 3x from both sides, and I have 14 equals negative 7x divided by negative 7, x equals negative 2. So there's half my answer again. I've got negative 2. Okay, and now I just need to plug this in to one of these, and this one is the easiest. So I have y equals negative 4 times x, which I found, which is negative 2, so y equals 8. Okay, I've got a few more, and we will do that on the next video.